Hi, my name is Damien. I'm managing with Network to Code, and today we're going to talk about how would you go about extracting the source of truth from your network, and specifically with a solution developed by Network to Code named the Network Importer. So let's look at the agenda. So first, we'll talk about why. Why do you want to extract the source of truth from your network? Then we'll move on to what do you need to consider? What are the different challenges that are ahead of you if you want to get into this task? And then we'll look at some of the solutions that we apply to this network importer and how we are actually solving those challenges. And then to close the sessions, I want to help you know and explain how you actually can actually get started with this solution to import your own source of truth from your network. So first question is really why do you need to extract the source of truth from the network? And this idea is the different train of thought in the industry when you talk about source of truth is that something that you should even import from the network, assuming the network is kind of not clean and not organized. Do you want to start from something clean, or do you want to just carry over a lot of this legacy? And my personal take is it should definitely be manually crafted, and you don't want to import everything. But at the end, the amount of information that you need to import is just so large, and human make mistakes all the time. So you definitely need to have something that will assist human in this process, and that's really what we're going to talk about today. So the problem statement is like, usually there's and we believe definitely is that at Network to Code that to really be able to do a proper automation, you need to have a source of truth. So the minimum requirement is to have an inventory, but then very quickly you need to have the source of truth. And if you're building a greenfield network, that's usually a lot of the time what we're using to explain automation tools and solution. It's kind of easy. But if you want to automate a brownfield network, that's really where the challenge is. Like if the network is already there and if the network is your source of truth, how do you go about transitioning what I call from A to B? Is like transitioning from my network is the source of truth to I have a proper centralized source of truth. And so if you look at the steps, again, day one, you have your network, it is the source of truth, and you want to build a new one. So what you're going to do is, you're going to import everything. For example, and I always say, okay, I transfer my source of truth. And I'm in these situations where I want to be able now to push changes to my network, from the source of truth. And that's, the definition of the source of truth is like if you have, when you have everything automated, then the changes should be triggered from the source of truth. Now, the challenge is, there's usually a lot of time that will happen, or it's not like just after an import you will be able to start making changes. First, you will need to do some, curate a little bit the data. You will need to look at it. You will need to organize. You will need to clean it up. And you also need to start working, for example, on your configuration templates. And when you're working on all of that, it can take, in base cases, that will take weeks. In most cases, that could take months. And what is happening is during this time, there's usually, still a lot of changes that are going on in your network. So now you're in situations where you have, two sources of data. You have the network, which is still, for real, the real source of truth, as long as changes still go straight to the network. And you have yet this, future source of truth that you're trying to build that start, to be disconnected with your network. And that's really where some of the challenges are, is like you need to be able to start maintaining a diff, or what we call is calculate the drift between your current source of truth, which is your network, and your future source of truth that you're trying to build. And being able in this time to actually, manually review the diff, understanding what is changing, and potentially decide if you want to keep, importing things, or if you want to import only part of it, and all of those different challenges. So that's really some of the explanation of what are the challenges, why you want to do that, and why you want something that is able to import, but also something later on that will be able to give you control on what you want to import. So now, as you get into this journey, what do you need to consider? Well, the first question is, what do you want to extract? What do you want to import? There's, so much information that can fit into a source of truth. Not everybody will need all of it. But if we look at the basics, there's all about the devices, the interface, the IP addresses, the VLAN, the cabling, potentially the SELs, routing protocol, DNS. And as you look at all of that, and as you start looking closer, then you need to think about all the different properties of each of those elements that you need to import. Like for example, I'm just using some of them as example here, but if you look at the device, we need to look at, the name, the role, the site, interface. Usually we look at the descriptions, the type, what is the mode, is it layer 2, layer 3, the IP address is the VLAN. And then for each of them, you need to really start, and describe, like, understand where is this information today. And the first thing you realize is, first, there's definitely some challenges because some of those information, they might not be easy to gather. Like, for example, if you look at the interface, getting the type of an interface, like the real type, like is it a 10 gig base T or is it a 10 gig SFP, is something that will be really hard to extract from the network, from the devices themselves. It's usually not part of the configuration. You might have to go into like some specific CLI command for that. And then when you get there, really having a good understanding from the show inventory, for example, will requires a lot of very specific platform specific command and all that. So it is a quite complicated task. Now there's all the other information, like the role, for example. What is the role of those interface, the role of this device, things that you definitely want to have in your source of truth that may not be there or easily available in the first place, or that might be like packaged into the host name of the device and you need to find a way to extract. But without going into the details, the idea is that there's definitely, it's very important to start looking at everything you want to import and understand exactly where it is, build a spreadsheet and look at all of those different elements and understand where you will get the information. Then there's the notion of the scope of the information that you're looking for. Like, for example, if you look at an interface configuration, the scope of that is a device. Each device has its own list of interface. Each interface has its own configuration. So technically, as you import those devices, as you import those interfaces, you can really look at them individually. I can import all of my device, all together, or I can import them one by one. That really doesn't matter. Now, the challenge is about all the resources in your network that are shared across multiple devices. Like, for example, the VLANs, the VRF, the prefixes that can be shared across the rack, it can be shared across multiple devices inside a site. And so you may want to make sure that you don't end up with, one VLAN 100 per device, for example, when you import everything in source of truth. In your source of truth, you want to make sure that you reconstruct this proper view, that you have one VLAN that is the same across multiple devices, and some of those devices might not even have an IP address on it, but nonetheless, this VLAN is itself associated with a prefix, and you want this association to be captured. So there is the challenge that to properly import everything, you also need to look at this multi-device system, and that's also a big part of it. And that's for all of these reasons that, at Network to Code, we decided to, start working on this tool called the Network Importer. And then now I'm going to walk you through that and for the last part of the presentation and try to help you get started. So what is the Network Importer? The Network Importer is, it's first a CLI tool and a Python library. And it has this ability to discover the network, discover the current state of the network from a lot of your different devices, from reading the configurations, but also getting information from the CLI. And what it does best is actually compare that and give you a diff. And it basically does a comparisons with your current source of truth, and it will tell you, like, here's what different between your network and the source of truth. And that's really how it will be used most of the time. Now, because it is able to do this diff, it also has the ability to actually import. And maybe the name should be more network diff something, but we went with the network importer. And then, if you want, then you can also import everything into your network, your source of truth in an idempotent way. So that if you actually repeat the process multiple times, you will always ensure that the source of truth is exactly in the status that your network is currently in at the beginning of the process. So now if you start to look a little closer, the network importer, it is a tool that is designed in Python, and at the heart of it, it's mostly using Batfish, Nornier, Napalm, NTC templates, and PyTS for really extracting information from the CLI. So we'll talk into more into details on what is the role of Nonier, what is the role of Badfish, but those are some of the main components that we're using. It really stand in between the network device and the source of truth. To work, you need to provide an inventory, and then so we'll talk about some of those different components one by one later on. If you look inside, there's really three main pieces. There's first what we call the diff engine, which is really something, an engine that has the ability to do these comparisons, to generate those, diff reports. And it is based on two sources of information. We have what we call those adapters. So the idea that you have a source of truth adapter that is in charge to, communicate with your source of truth, get all the informations, make all of the updates as required. And that will basically take all of those informations and convert that into a shared data model, the one that the diff engine understand. And on the other side, we have the network adapters that will get all the information from the devices, the configuration, the CLI, and that will again translate everything into this shared data model. And then based on those two information coming from the adapter, then the diff engine has this ability to do these comparisons, decide what needs to be updated in one side or the other. Where it gets interesting is the adapters are, um, replaceable. Like, where here the source of truth adapter is generic, like the default one, shipping with the network importer has been designed for Netbox, but the solution is made that it will be totally possible tomorrow to actually have a new network source of truth adapters that has been designed for another source of truth. We could have something to integrate with, ServiceNow, for example, in the futures. Or if you had your own source of truth with your own interface, then you'll have the ability to develop that. So that's why we're talking right now in not in specific terms or specific source of truth. So if you look at all those components we're buying, first the inventory. So the inventory today, it is based on Nonier. You need to provide a Nonier class. You need to have some parameters. So the default one is designed to work with Netbox. But that is one of those components, like most of those components, the inventory and the adapter, that actually can be extended, and that could even be completely provided by the user. They could, redefine some of the functions that are providing. So there's a lot of extensibility into it, and that's really something that kind of learned the hard way. And that's why that when this project is going to come out, it's going to be Network Importer 2.0, is because the first versions was not as extensible as it should be, and we realized that as we got into all this journey, what we realized is really there's when you come about importing the source of truth, there's really this 80-20 rules. A lot of the customers, they will have 80% of things that are the same and then we can reuse, but there's really 20% of the logic that will be specific for each customer. Each customer will want to import, some specific information in its own way, its own classification. And so we really, for 2.0, we really redesigned this whole project to be extremely extensible, from the inventory, from the adapter, from the diff engine. Everything has a lot of extensibility into it. And if you have the the Python skills, then you can definitely start enhancing and all of that, and adding your own business logic layers on top of what is already there. So moving on to the diff engine. The diff engine is really, as I described, something that has a shared data model that is defined that you can also extend. But it's fairly simple when you look at it from the device, the interface, the IP, all those things that are supported that we talk about later. And then as long as each of the adapters, convert everything into these models, then we'll be able to do comparisons. We'll be able to generate those reports and tell you exactly down to each attributes what is different between the two data source. The source of truth adapter, for now, the one that is shipping with Network Importer 2.0 is designed to work with Netbox, specifically over Netbox API. So it supports the APIs for 2.8 and 2.9. And in the future, I definitely expect to see more adapters coming for different source of truth and have a more pluggable system. And as I mentioned earlier, you have the ability to enhance this adapter on your own and add your own logic to add support for new objects that are in netbox or for custom operations that are not defined by default. On the network adapter side, so here, as I mentioned, we're primarily using Batfish. So why Batfish? And Batfish has been a really great tool. And we're using it in a way that is primarily use case because Batfish, if you're not aware, it has this ability to parse all of your configurations. And what it's really good at, it will actually completely build a logical model of the network. You will be able to reproduce and rebuild your routing tables and the access list and have a complete understanding of how the network will behave. Here, we're really using it for its parsing engine, and because it is able to take configurations from a lot of different devices and produce this vendor neutral model that is really helpful so that we can extract all the information about the interface, the SELs, and all those different things. So that's really what we're using it for right now, and because it has really a number of elements it supports in the configuration is larger than most other parser out there, and the number of vendors that are supported for sure. So on top of that, we also have this ability to collect additional information from the CLI, like for example, neighbors information from LLDP or CDP. And in some cases, we're also having the ability to collect information that are sometimes better returned from the CLIs, like what is the real list of VLANs that we have, or what is the additional information. But that there is this option to collect some information from CLI. When we need to talk to the network devices, there is a base support that is based on Napalm, but you can also provide your own drivers, and you can also have you have the ability to collect information not just with Napalm, with your own system, like using NetMiko directly or PyATS as you want. If we look at what we are importing right now and where this information is coming from, so but in the base versions, the network importer, import the interfaces, the IP addresses, the VLAN, the prefix, and the cables. So most of them are extracted from the configuration, except the cabling that has, I will say, partial supports. And from the CLI, we're able to also extract the cabling and the VLAN right now. And as the solution evolve, I definitely see this list of elements we can import from the network increasing, but usually having a full understanding of the VLAN, the prefixes, like for example, the interface, we'll be able to extract the all the interface, but also reconstruct the lag and the lag members, all of those different things that are not always available in all the solution out there that will just give you the list of interface. In terms of devices that are supported and type of devices, we're really bound to what Batfish and Napalm support. So Batfish out of the box has good support for Cisco iOS, Cisco NXOS, Cisco XR, Juniper, Arista, and Napalm as well. So those 5 platforms are definitely supported. Now beyond that, Batfish also supports Cumulus, Cisco ASA, Palo Alto, and there are some community driver on Napalm for it. So while I haven't tested myself, I would assume that those should work decent. I will say out of the box, definitely more testing will be required. And just to be clear, for example, if there is a community driver for something like Fortinet in Napalm, but if this specific vendor is not supported by Batfish right now, then we won't be able to support that, because really most of the information right now are coming from Batfish. So what's next on this project? So first, the project itself, we're planning to making it available in GitHub. I'll say, if not by the time you're watching this video for Interop, hopefully, sometime in October, then I expect, in the future, we'll definitely have a lot of works to improve on having more supports, more objects, as I mentioned earlier, having, better support for the access list and the routing protocol. That's one of the reasons where Batfish is really differentiating from all the other solutions out there. It has this ability to provide really good data models and parse and return structured data for all the SELs and routing protocol, which is extremely useful information that we want to leverage in the future. And then more of a guess at this point, but I definitely expect at some point I'll have to look at building a netbox plugin for it and having a better integration, so that from the UI we will be able to get some information on what is the drift between the network and netbox without having to go back to the CLI. But no commitment on that part yet. So now that you have a good understanding of, again, what is the challenge, what you need to think about when you get there, and how we went about it, and solve that with the network importer, let me explain what you need to do to get started with this project. And the first thing is, if you want to get started with the network importer, you need to have an inventory. You need to have all of your devices already in Netbox. You need to make sure that those devices have the proper platform and the napalm drivers defined, because that's all of the information we'll use. There is a way where you can, go in the configurations and define your own, but my recommendations will, use the NetMiko platform naming convention for your platforms and the napalm naming convention for your napalm drivers. Meaning, when I say NetMiko, it means for a Cisco iOS that will become Cisco underscore iOS, where for Arista that will become, Arista underscore EOS. That's the way NetMiko is naming the platform, and that's what we're trying to use as a default function. Ideally, you also have your primary IP defined, and it's not mandatory, but if you already have the configuration backup available, that will definitely help with the process. If you don't, the network importer had kind of a small configuration backup engine where you will be able to retrieve the configurations from your device, but I will say if they are already available, so that's definitely a plus. And then to be able to leverage Badfish, you either need to be able to start Badfish in a Docker container, or you need to have a cloud account with their Badfish Enterprise service. So if you look at Badfish specifically, if you want to provide your own configurations, one thing you need to be aware is that the configuration cannot be flat into a directory. It actually needs to be organized in the way that is recognized by Badfish, which might, if you're not familiar, Badfish actually expects your configurations to be in a subdirectory named configs. And that's because he also has the ability to take on more information. Like you could provide more information about the layer one information about your network, or some show commands, some additional things. We don't necessarily need all of those information in there, but technically if you have them, if you're already using Badfish for something else, that definitely won't hurt to have all those additional information available. And then once you have all of that, you can also start a Badfish into its own containers if you don't have one. And here I have a simple one-liner that will just help you run a Badfish containers and expose the default ports in 9997 and 9996. Now, if you don't have your devices, if you don't have your inventory, and if we go back to what I was saying earlier about the challenge around the device type, my recommendation is, because it is so hard to import the device type from the devices themselves, the recommendation if you're using a solution like Netbox is actually to have spend the time to define proper device type. And device type in Netbox are those like template of devices where you have all the interface predefined, and you'll have proper type of this interface. We'll be able to define that you have those. Some of them are 40 gig and 100 gigs and 10 gig copper fiber. You'll be able to define all of that, and then you could use the solutions like the inboarding plugin that we developed for Netbox, for example, to build your inventory and to use all of this device type to get to a point where all of your devices will be in Netbox, all of their platforms and napalm driver will be properly defined. You will have hopefully, match already your device type, so you already have all of the default interface in there with the proper type and all of those information. So it's more information that we won't have to guess or insert if they're already defined. And then as you start and move on and run the network importer at this point, to be able to extract the source of truth from the network and import that into Netbox, then you will just have to create the virtual interface, like the VLAN interface, the loopback and the lags, and it will create all of that, update everything, but it will also conserve at this point all the specific device type. And then when you're there, you probably have to run that multiple times. Again, run those diff, calculate the drift between your network and your source of truth to the points where you feel good about it. And then at this point, you will be able to say, okay, now the network is no longer a source of truth. I have my source of truth in Netbox. And during this time, the previous steps, I was actually working on building this workflow, and now I can trigger changes to my network from the source of truth. So hopefully when you get there, feel free to send us a message, give us some feedback on the tool and on all of that. Hopefully that's useful. And if you have any questions, feel free to reach out to me. I'll answer questions just after this presentation. Otherwise, we're always on the Network to Code Slack channel. Thanks for your time.